Ready to go? Good. Good morning, good afternoon for the online participants. Pleasure to see you here this morning. My name is Stefan Ullenbrock. I work for the World Meteorological Organization, and I welcome you to the session on Cryosphere as a driver for global change. A driver and a victim, probably we can say. But before we start with the official program, it's a pleasure to give the word to the director of the ICCI, Pam Pearson, who is well known in these circles, and she will do a short framing and introduction to the session. Please, Pam.
Thank you so much, Stefan. And it's a real pleasure to welcome everyone here. I wanted to context this by talking about the evolution that I've seen in the role of cryosphere at COPs in particular, since about 2007, 2008, when I came back into these rooms after being a part of them during the Kyoto negotiations, actually. And when I was first involved, the thing you would hear all the time is, oh, the Arctic is the canary in the coal mine. And then that became the cryosphere. And then we added the third pole and mountain glaciers. And that's all very important, but even more so, especially I would say since the conclusion of the Paris Agreement, so the past 10 years, what we've been seeing is cryosphere moving from an indicator of climate change to a driver of climate change. And that's what we're going to be focusing on today. I need to say, though, that this is still not all that well understood in these rooms. You know, the connection between ice sheet loss and sea level rise for the small island developing states, the connection between glacier and snowpack loss and downstream impacts, whether those are catastrophic glacial lake outburst floods or whether they are decreasing or increasing water resources over time, again, not well understood. You're going to be hearing today about something that very few people focus on, which is polar ocean acidification, which is already at levels that are damaging shelled life, and that's only going to spread. And the other factors are sea ice at both poles now. When I first started, we were only worried about the Arctic. Now it's decreasing, has decreased just as much around the continent of Antarctica. And permafrost, which in a sense has a global impact. Again, you see it locally when it subsides, but the emissions from permafrost are going to make the task of reaching net zero much harder. And so these are the 5 dynamics that we tend to focus on here in these rooms, and it's really important to get this science out so that negotiators understand that we need not just to talk about climate ambition, we need to talk about urgency, we need to talk about timing. Overshoot should not be acceptable, and we need to minimize it as much as possible. And there are plenty of things out right now about how to minimize overshoot and come back down to 1.5 and even below 1 degree by end of century using carbon dioxide removable techniques that are both feasible and sustainable after we bring in renewables to the extent possible. So huge tie between cryosphere, climate ambition, urgency, and I look forward to the presentations today.
Thank you very much, Pam. We have an exciting session with 4 keynote presentations, as presenters are all here, and then we hand over to a panel discussion. And for the keynote presentations, we have 4, and yes, we have a busy program, so I would really appreciate if you make my life as moderator easy and keep the time. And because it's so hot here, we start with the polar regions, and it's now a pleasure to invite Dr. Florence Coloni. She's in the Scientific Committee for Arctic Research and at this university, in our Federal Research Center in Trieste, which I don't have the name correctly. Florence, please, on ice sheets and sea level rise. Over to you. Thank you.
Thank you, Stefan. Okay, so the idea here was to give you an update about what we know, what is not going right for both the ice sheet that we have at the poles, the Greenland and Antarctica. So what we know is like sea level is rising more and more and more and more and more. So the current rate is about 3.4 millimeter per year, but it has doubled since the 90s, actually. And that shows you that the sea level rise, the rates of sea level rise, is not linear, it's exponential. So it means that it's accelerating and it will continue to accelerate. More than half of sea level rise is due to the ice sheets melting, okay, and the mountain glaciers. And the other part is mostly due to the ocean thermal expansion. Okay, this shows you that the ice component now has become as leading the signal, and is giving this huge acceleration to this sea level rise. In terms of Greenland, Greenland has been melting, and it melts faster than we thought. Okay, we have been observing amplified summer melt over the past decades, and every summer is warmer and warmer and generate more melts actually. And the fact is that because it changes also the color of the surface, it changes the reflectivity of the surface, the albedo, so it just amplifies further the melt at the surface. So it's a positive feedback. Then we have been observing that the northern ice shelf are more vulnerable than we thought too, because we thought they are close to the Arctic cycle, but it's not the case. Actually, they also have experienced more than 30% of reductions since the mid 20th century. So that's a big signal for ice shelves that are facing directly to the polar Arctic cycle, actually. And then what we observe with satellite, that there is a sustained mass loss from Greenland, and we have been expanding it back to past before a bit the first satellite signal that we got, and it has been a continuous mass loss even since the 90s. So it's not only that it started in the since 2000s when we launched the satellite, but it started well before. So Greenland is melting fast. Same for Antarctica. It seems that it was a big block of ice that was very stable, not very much reacting to climate change, but that's not the case, because if you look at this graph, for example, here of persisting mass loss, I mean, this shows you that Antarctica has been losing the mass exactly as for Greenland, okay? What is more important for Antarctica is that all the glaciers that reaches the coastline that start floating on the oceans are also vulnerable to ocean warming, actually, because they melt from below, okay? And this is the main way the Antarctica is losing the mass right now. And in particular, in this western part that is facing South America and the Pacific, actually, it's really a vulnerable part, because the ice sheet there is really grounded below the sea level, so it makes the ocean warming more a threat to the ice sheet stability in this area. We have been observing some mass gain at the surface of Antarctica ultimately, and mass gain here, it's not a good sign. It's rather a signal of a warming, actually, because over Antarctica, the atmosphere is so dry, so cold, that you have a little moisture, so you don't have a lot of snowfall. But if the climate warms over Antarctica, the atmosphere can hold more moisture, and it allows more snowfall. So more snowfall, mass gain, but it's a warming signal, actually. So it's not a positive signal. Then, why sea level projections are so uncertain? So it's because all the interface between the ice, the atmosphere, the bedrock below, and the ocean are the one that we least know, actually, because we lack of observation to really understand the physics of the exchange of the heat from both the atmosphere to the ice sheet, or to the ocean to the ice sheet, actually. And because of those lack of knowledge, basically, we have a deep uncertainty that show up in the projections, and you can go to the IPCC report and you can see the huge uncertainty that there is on sea level projection. And mostly because this deep uncertainty is very important, because this determines instabilities of the ice sheet in the future. So if the ocean warms, those floating glaciers at the coastline, for example, of Antarctica or the northern part of Greenland, and if the atmosphere is warming and melting at the surface, this causes some instabilities, and those floating glaciers disintegrates, which allows the flux from inland Antarctica and Greenland to accelerate and discharge into the ocean. So those deep uncertainties that we have, they also determine the rate and the velocity of ice discharge in case of instability of those ice sheets. This reflects in the projections, as I say. If you look at the different grade of warming projected in the future, so from 1.5 degrees, that Paris agreements, to plus 0.4 degrees, that is the business as usual scenario, you can see that if we project very far in the future, like 2 centuries ahead in the future, the uncertainties on the amount of sea level rise is really important, okay? And this is due to this lack of knowledge at the interface between the ice sheet and the climate. So main message from that is, like, actually are more vulnerable than we thought from the last IPCC report, okay? But it has been a decade now since this report, so that's normal. But what we see, it's a trend that repeats from one IPCC report to another. The system is faster than we are able to monitor it and to understand it. So you don't underestimate the planet now because it's running ahead of us, right? Definitely. And 1.2 degrees, not 0.5 degrees, might already be too late for ice sheet. They're already melting more and more and more and more and faster and faster. Second point is like sea level projection underestimate the acceleration of ice melting, as I said. So it's important to understand that our scenarios are a little bit slower, okay? And so we are anyway committed to some sea level rise, at least half meter by the end of the centuries, because of the ice sheet absorbing the heat. They release the heat on very long time scale. So anyway, whatever we do, even if we mitigate to Paris Agreement, we will have a sea level rise at least half a meter. Thanks.
Super, Florence. Thank you so much. We take the 4 presentations, but please remain here and we take some questions in the next round. Next speaker will take us to the high mountains, and it's now a pleasure to invite Dr. Miriam Jackson. She held many positions in the past, but particularly would like to mention Norway Water Authority, but also lead author of IPCC, and she serves also the ICCI. Over to you, please, Miriam.
Thank you very much, Stefan, and good morning, everybody. Good afternoon, good evening to those online. It's a pleasure to be here. And I'm going to be talking about high mountain cryosphere. This is actually from a trip we had during SROC. This is Antisanas Glacier in Ecuador, and it's one of many glaciers that is shrinking very rapidly. And I'm going to be talking about high mountain areas. Where do we have high mountain areas? You can see here the high mountain areas are marked in brown, and we have high mountain areas on every continent, which means we also have glaciers on, well, actually on every continent. We have snow, we have permafrost or frozen ground. So this is a global problem, what's happening with the cryosphere in high mountain areas. This is quite a complicated graph, but this is showing the non-polar regions of high mountain areas. And we can see here again, the different parts of the world as they're divided up. And where we have glaciers and permafrost, the glaciers are marked in blue, the permafrost in purple. The permafrost is so extensive, it's not the same scale. Otherwise, all you'd see is permafrost. And you can see even in this part of the world, the low latitudes, we do have a lot of glaciers. In the tropical glaciers in South America, in Africa, even in Indonesia. And these ones are disappearing very fast. So how fast are they disappearing? This is a very busy graph with a lot of information. This is looking at the global changes in glacier mass between 2000 and 2023. The main thing to notice here is, do you see red or blue? Personally, I see a lot of red. This is a bad sign. The glaciers are getting smaller. The glaciers are melting. So we just see a lot of red on this graph, especially the last few years. And this is now including the polar glaciers. If we look at the global average, it's 5.4% in this period. That's not too bad, actually. It's quite a lot, but it's not too bad. However, let's look at a few areas. Caucasus and the Middle East, over a third. This is just over 2 decades. Imagine another 2 decades, another 2 decades. It's all gone. This is affecting millions of people. South Asia East, affecting many, many millions of people. This is over 20%. Again, this is a lot of glacier loss. Western Canada and the US. Cryosphere change is very important for Canada and the US. It's affecting them now. It's going to affect them more in the future. Central Asia as well. Not such a big loss, but Central Asia is very dry. Some parts of Central Asia are very dependent on glacier loss. It might not be a very big component of the river discharge, but it really kicks in when it's hot and when it's dry, when people really need the water. And those glaciers are also disappearing. Low latitudes as well. Again, here, the glaciers here are very sensitive. They gain mass and lose mass year round, a little bit different than most other glaciers, and they're also shrinking very rapidly. And the Southern Andes as well. So South America is really seeing the effects of this. And this is what it looks like on the ground. The glacier on the left is Engebren in northern Norway. I've done a lot of work here. Started working there in 1999, and it was 9 meters above sea level, the lowest point. It's now several hundred meters above sea level. You see at the bottom left, this is just over 2 decades. And this is what's really useful about glaciers, because we know the carbon dioxide is changing because we have measurements, but we don't really feel it. We know the climate is changing. We really notice that in the hot summer, and then we forget it in the winter. But the glaciers are seeing this all the time. They're recording it. They're very sensitive to small increases in temperature. So the glaciers really shows the reality of climate change. On the left is Fondelsbrain, and just over 20 years has, pretty much disappeared. And the same thing all over the world. Yellow glacier as well in Nepal. Looked very nice in the 80s and the 90s. It's now pretty much a very big ice cube. So Flo mentioned the ice loss from Greenland and Antarctica. Obviously, the ice sheets are very big. This is where a lot of the ice loss is coming. But what's interesting is even though the glaciers altogether have a small contribution to sea level rise, the current contribution is very big because they're melting so rapidly. So an average of 273 gigatons a year. The figures vary slightly depending on the source, but they all show a very similar pattern. But what's really interesting is just how much this has increased in the last few decades. For Antarctica, a huge increase, Greenland, and also for the mountain glaciers. And just from the first decade of this century to the next, it's increased over a third, 36%. And what's happening apart from sea level rise, how do these things affect people? How do they affect ecosystems? And this, again, is quite a complicated graph, but basically shows you the different high mountain regions of the world and the different effects on ecosystems. It's affecting ecosystems in the tundra, the forest, lakes, and rivers. And this is showing the recorded changes. It's also quite an old graph, I admit. The changes are happening globally. We just don't always have the articles and scientific evidence to assess that, but we know the changes are happening everywhere. Also for people, all kinds of effects. Tourism is being affected. Agriculture, especially again, areas that are very dry or dependent on glacier melt in the summer, areas that get a lot of snow melt as well, are really seeing the effects of cryosphere loss. Infrastructure, a lot of hydropower is very much affected by changes in glaciers and other cryosphere. Migration, we don't really talk about this much, but people, if they're losing their meltwater, if the agriculture is being affected, they're going to move. And that is often a challenge. And then also cultural services. This is something that you really can't put a value on, but in many parts of the world, people have a very spiritual connection to the cryosphere, to snow-covered mountains, to glaciers. We see this a lot in high mountain Asia. We also see this in other areas, in European Alps, in Norway. It's a little bit more, people might not call it spiritual, but I know that, people look forward to the snow arriving and going skiing. There is certainly a spiritual connection there. And especially as this is the International Year of Glaciers Preservation. So it's really, we really need to work on this and decrease our emissions, because this is the best way to preserve glaciers. And also it's the start of the decade on cryosphere action. I'm sure Neil will say more about this. But this is, we really need to focus a lot on the cryosphere because these changes are happening so rapidly. And also the rate of change is getting faster and faster. There's a lot of changes in the risks as well. You can see here sort of a mountain scene. And as the permafrost melts, the slopes become unstable. We get glacial lakes forming. We get more avalanches in different areas. Perhaps we get more wet avalanches. And then we also get effects on livelihoods, on hydropower, for example. Again, this is what it looks like on the ground. This was a graph in 2016. It's actually from a glacial lake, a very small one in China that nobody really took much notice of. And then when there was a flood from this lake, this is what happened in Nepal. So a hydropower plant that was quite new was totally wiped out. And this is transboundary. The hazard was in China, the impact was in Nepal. This is another challenge we have when trying to monitor this, do mitigation, such as lowering the lake or putting in early warning systems. There's been many events in South America. An event in 1941 in the Peruvian Andes killed over 4,000 people. That was about a third of the population at the time. There's been at least 160 of these floods in the tropical Andes since the Little Ice Age. India is very much affected by climate change, especially by the cryosphere. There's been several disasters in India in the past decade. In 2023, there was a graph from South Lanak Lake in Sikkim. And I'd heard about this lake beforehand because I knew someone who was working on it, who had written scientific articles saying, this lake is changing, it's getting bigger, it's going to flood, it's going to be a disaster, we need to do something. They'd started doing something, but things often move slowly. This is, I think it's Chumthang, after the disaster. This is quite a large town you see there in the middle. Huge hydropower dam in the middle, totally wiped out. That was $490 million worth. 80% of the town there was affected by this flood, and many other towns. Over 25,000 buildings, over 30 bridges, agricultural land, several other dams. So the total cost was many billions of dollars, also human life as well, and you can't really put a value on that. I'll say a little bit about permafrost. This is frozen ground. Permafrost, as I showed on one of the first graphs, is very extensive. It's also a little bit harder to see the changes. I showed some nice glacier photos. You can see the changing. If you see permafrost, it's not quite as visible, but it is changing rapidly, and it's also affecting lots of people. Here are some of the surface changes we can see. It's often one of the triggers for glacier lake outburst floods. We've seen this several times, including South Lanark and Sikkim. In Malamchi in Nepal, there was a big effort to have a new reliable source of drinking water for Kathmandu, especially where millions of people live. And just after this had opened, there were several cascading effects: heavy rainfall, glacial lake outburst flood, unstable sites from permafrost, and altogether basically wiped out this brand new water supply. Chamoli as well in India in the Uttarakhand is also very affected. They had over 100 people died in 2021, I think. This was mainly permafrost and then a big debris flood downstream, killed over 100 people and wiped out several hydropower plants. And let's not forget snow. It's a little bit harder to measure than glaciers because it varies from one year to the next. We do see generally decline in the snowpack. This is a very nice figure from the European Alps. We see the same thing in the Hindu Kush Himalaya. Actually, one or two basins that are getting more snow, but generally most basins in the Hindu Kush Himalaya are getting less snow. The snow melt is very important in some of these basins. In the Indus, it's not really glaciers they depend on. It's actually the snow melt. In the Ganges, it's not so much, but still 10% is from snow melt. So these changes are happening very rapidly. Also, we're seeing the variability from one year to the next. It's getting greater and greater. So it just makes it much harder adapting to this. So a quick overview. As you can see, glaciers, snow, permafrost are affecting hundreds of millions of people in mountain areas, billions more downstream, and ultimately everybody globally because of current sea level rise. Thank you.
Excellent. Excellent. Thank you so much, Miriam. So it was quite a masterclass for all elements of the cryosphere, the high mountains. And after we visited the polar region, it's now also time to look at the cryosphere aspects of the oceans. And it's a pleasure to invite Dr. Tiago Monteiro. Tiago is a professor at the Federal University of Bahia here in Brazil, and he will bring us to the polar oceans and the carbon cycle. Thank you.
Thank you very much, Stefan. So, hello everyone. I'm Tiago Monteiro from the Federal University of Bahia here in Brazil, and today I'm going to talk about a little bit about the polar oceans and the global carbon cycle, and it's important for all of us in this planet. So by the polar ocean here, I'm talking about the Arctic Ocean in the north and the Southern Ocean around the Antarctica. And these regions have a huge, vast area of sea ice that is simply the seawater frozen. And the sea ice cover is very important for the balance of energy in our planet because they reflect most of the sun energy that reach the sea surface, the surface of the sea ice. And this is important because most of this energy come back into the space, mitigating the temperature in our planet. So the sea ice is very important to control the temperature in the Earth's planet. And this is because of the high albedo, that is the capacity of the surface to reflect the sun's energy. And we can see this actually here in Belém very much. If you go outside and stand there with a black shirt and then with a white one, and we can feel very hot at the in a black one. So this is very important, not just there in polar oceans that is far from many of the regions, such as like here in Belém, for example, but to many of us in our planet. And another important thing about the Southern Ocean and the polar oceans in general and the Southern Ocean is because the regions are very important to taking up carbon dioxide in excess in the atmosphere. And the ocean as a whole taking up about 25% of the excess of the carbon dioxide into the atmosphere that the human release into the atmosphere. And only the Southern Ocean taking up about half of this excess of the carbon dioxide that is absorbed by the ocean. That's a huge amount, even though this region covers just about 20% of the global ocean. So in this figure here, we can see, and the red color indicate that the ocean release CO2 to the atmosphere, and the blue color indicate that the ocean absorbs CO2 from the atmosphere. And we can see very well that the ocean that surrounds Antarctica, that is the Southern Ocean, it's almost blue, indicate that they absorb most of the carbon dioxide. This is very important because they mitigate the global warming, you know, because otherwise most of the huge amount of the carbon dioxide would be at the atmosphere, warm up the planet. But these have a high cost for the oceans because they become the ocean more acidic. So the huge amount of the carbon dioxide that's taken up from the ocean change the chemistry of the ocean. And this is very dangerous for many, many organisms that live there because they are very sensitive to the change in the chemistry of the ocean. The next, please. Okay, so the polar oceans are also very important for the global ocean currents. So in this figure here, we can see our planet in a different perspective, from the perspective of the ocean. And we can see in the red arrows, the sea surface oceans currents, and in the blue colors, the blue arrows, the deep and cooler currents. And we also can realize by this figure that the Southern Ocean have a central role in the global global ocean circulation. So most of the water that surround the global ocean in every region in our planet actually surround the Southern Ocean. The Southern Ocean is very important to connect all of the waters from for the ocean in this region. So it is very, very central to transport heat, nutrients, and gases throughout the global ocean. And this is important because many organisms that live in the ocean depend on the nutrients that is delivered from the polar ocean, such as the Southern Ocean, for example. And so the Southern Ocean is important because they underpin a huge variety of organisms throughout the global ocean. And these organisms is the huge variety of organisms, from a very teeny organism to the penguins, whales, and seals, for example. And they sustain a huge amount of what we call blue carbon, that is essentially the living organisms in the ocean that maintain the carbon inside the ocean, you know? Well, and we already see now many impacts in the Southern Ocean and the Polar Ocean as a whole, such as the warming. So we already see higher temperature than the normal at the sea surface, in the ocean, and at the atmosphere. And this increase in the temperature have driven the ice loss and ocean freshening that is very dangerous for the ocean circulation. And we already see a decrease in the pH of ocean, in the Southern Ocean, driven by the huge amount of the carbon dioxide that is taken up in this region. So What we need to take as a take-home message here is that the polar oceans are very important for all of us in this planet, not just to this region, to these beautiful regions of the southern, like Southern Ocean and Arctic Ocean, for example, because they are regulators of the Earth's climate and mitigators of the climate change. And they act as like an engine of the global ocean circulation by distributing huge carbon and nutrients throughout the global ocean. And these properties underpin a huge amount of marine life across a vast area of the global ocean and ensuring food security for the humankind everywhere in the world. So this is very important to keep one within the 1.5 degree to enable these regions to maintain this ecosystem, intact and recover from impact. So salvaguard the polar oceans ecosystems is very important, not to the organisms that live there or to maintain the beautiful environment there, but it's important for all of us, even in places far from these regions, such as like here in Belém, for example. That's it. Thank you very much.
Thank you, Tiago. Thank you. Very helpful. So after we went through all the key elements of the cryosphere, it's maybe now the time to look at some global programs before we go into a Q&A. I know some people have to rush to the next meeting as well. And it's now a pleasure to invite Dr. Anil Mishra. Anil works for the UNESCO International Hydrological Program, and he will give us an overview about the cryosphere decade, the International Year for Glacier Preservation, and the IPY. This is a lot in 7 minutes. Over to you.
Well, can we have, yes. I need to talk about International Year of Glacier Preservation, Decade of Action for Cryospheric Sciences, and International Polar Year. But before I go into that, we heard from the scientist about the gravity of the problem. What science for climate action we are proposing out of this session? And if I just say climate action, something came up in my mind. What are climate action? We need to reduce greenhouse gas emissions, so reduce. And if that is not possible, we have to adapt. And if that is not possible, we have to move. But where to move? We are feeling everywhere from Antarctica, Arctic, Himalayas. So I think now science needs to find that answer. So I will try to summarize what we are doing within the context of these 3 global initiatives. But Miriam already provided very detailed information about that paper. And if I just summarize globally, from 2000 to 2023, 6,500 gigaton humanity lost that glacier or cryosphere from around that time. And if you translate that in terms of sea level rise, that's roughly 18 millimeter and impacting 700 million people in the lowland and coastal areas and small island developing states. So impact doesn't stay up in the mountain or in the Antarctic, Arctic, it goes to all over the world. And if we look at also impact on our culture and heritage, 35,000 glaciers are in 110 designated World Heritage Sites, biosphere reserves, which are keeping our heritage, our language, our culture. And by 2030, by 2050, 1/3 of those glaciers will be gone. So we will also lose our culture, our heritage, our language. So this shows the gravity of the problem. Now, realizing this fact, and I don't want to go into all the details, 3 of the keynote speaker already provided. And Tajikistan brought together a resolution, International Year of Glacier Preservation 2025, which is the implementation is co-led by UNESCO and WMO, and you have been in the part of the process. So very quickly, we established advisory group, scientific advisory group, and 4 task force, and Miriam sitting here is serving in one of the task force, global campaign, international conference, capacity building, research and monitoring, policy advocacy, which is also led by ICCI. Pam just left, who gave the opening remark. So these 4 task force bringing together a huge network of glaciers, policy advocacy, campaigners, and did many activities. So we started this year in Geneva with the curtain raising event, and then we went to launching of Glacier Day in Paris and in New York. We had a glacier conference, and then we are having this discussion now. And I would like to invite you for the closing ceremony next year, 1920 March in Paris. At the same time, I think I would consider this as an outcome of the glacier year from year to the decade, International Decade of Action for Cryospheric Sciences. There are 3 words. We need to walk the talk. So we need to take action, cryospheric sciences. And it is very relevant to have in the Science for Climate Action panel. So what we are, why UNESCO was tasked to lead this? Because of the competencies. Even from 60s, we produce how much glacier and snow is available in the world. We call for monitoring of glaciers. We establish snow and ice working group in the Latin America and Andean Glacier Water Atlas, glossary of glacier, old heritage glacier. So all this scientific credibility, UNESCO is tasked to lead the implementation. And in March, we had a brainstorming session, and there was a high-level lunch by France, Tajikistan, and UNESCO during Ocean Conference in June. But with the support of WMO, ECMOD, and many organizations, we prepared 5 background documents: scientific observation, monitoring, education and capacity development, policy, advocacy and campaign, financing the bridging the financial gaps. So these background documents gave us a draft, overarching challenges and milestone for 10 years. Now we are working on it. And global cryospheric monitoring, actionable cryosphere prediction, mitigate cryospheric hazard, climate resilient adaptation, and coordinate cryosphere science to protect cryosphere. Under these milestones, we have several challenges, or under that challenges, we have several milestones to achieve. And we invited let me go back. We are finalizing that on 8 and 9 December in Paris, those milestones. And after that, we'll be calling for expression of interest to serve in the working group. In the meantime, we are also closely working with preparation of International Polar Year. It will be 5th International Polar Year after roughly 25 years, 2032 to 2033. We are working very closely with the International Polar Board, WMO, International Science Council to develop synergy. The Polar Year preparation is a bit lucky because they are preparing already for 10 years, whereas the decade just started, we have to catch up. So there are definitely different synergies, and we are trying to figure out the milestone that Polar Year is already trying to achieve, how to align that to the decade. And the synergies and opportunities, not only with the Polar Year, but also International Ocean Science Decade for Sustainable Development, that is also UNESCO leading, International Decade of Science for Sustainable Development, and International Year of Glacier Preservation. So there are 3 decades and international year, 2 international year. We really need to develop synergy. And we already united for the decade. We have all these organizations. You can see logo of WMO, CNRS, many scientific organizations, the SCAR, International Cryosphere Research Center. We would like to invite all of you because this is our shared responsibility. We need to work together. And as I said, I would like to invite you to Paris in March 2019-20 to launch the technical decade, to launch the International Decade of Action for Cryospheric Sciences. We have website already. Please provide us your feedback. Let's work together to address these profound challenges. And I think we will get some scientific solution for climate action. Thank you very much.
Thank you. Thank you, Anil. So we have now time, few minutes for Q&A with the four presenters of this morning. They are still all here. Now we have the panel. We start in a second. The first question by, please, James.
Thank you. Just worth flagging out that really the IPY is clearly in its timing right before the third GST. So what findings are you hoping to bring through there? And is that being considered as a way to feed directly into policy from this research into the third global stocktake? It's ready for it.
Well, we've been talking to IPY Secretariat. I guess there are 4 organizations, and 2 of them are sitting in the UNES ad hoc committee. So the preparatory work done by IPY will be incorporated or aligned into our overarching challenges, and particularly related to policy. It's very much we are in the process because we just started setting our overarching challenges. And I attended several IPY meetings, and they are part of our discussion. So as I said, and I don't know who will come from, I think Pam will come to Paris on 8 and 9 December representing ICCI, but we have also from ISCAR, from International Science Council, from WMO. So we will work together and make sure that we avoid duplication but develop synergies.
Yes, in a resource-constrained environment, it's really important to, build on each other's work. That's certainly true. Other questions for the 4 keynote speakers? I think they were really good, but maybe also so clear that we don't have questions at this moment, and we all wish we would have a bit of cryosphere in the room. No, then thanks again for the 4 presenters. I really found this is online. That's recorded. If you don't mind, we put it also on the website. And I would like to acknowledge one colleague, Mike Sparrow. I just verified he cannot speak because the link is somehow not established. But actually, Mike Sparrow was preparing everything. My colleague who's in Geneva at the moment, and he is one of the colleagues who's watching us now. And I just felt he deserves a recognition for doing all the work. And now we hand over now to the panel discussion. I would like to the front here, my colleagues. We have 4 panelists, and I would like to invite Ellie Miller, Josep Bossum, James Kirkham, and Laura Morales Moncayo. These are 4 cryo experts, wherever you want. There's no seating order, but James, if you don't mind, we start with a lady. Laura, maybe we have a couple of questions for you prepared, and but it's not so important to give long statements that are all completely correct and whatever. If we are able to have an interactive discussion, I think that's more entertaining for everyone. But I would like to invite each of you for a short statement, 3-4 minutes as you wish. Maybe briefly introduce yourself or your background, but not your 10-page CV, just 30 seconds. And if you could reflect on, based on your research, as you as an expert, what do you feel is the cryosphere changes that are most tangible, but also maybe most underestimated by policymakers? Laura, do you want to start?
Yes. So hello, everyone. Does this work?
Now it should work.
Hello? Yes. So hello, everyone. My name is Laura Molares. I'm a PhD student in polar geomicrobiology at Queen Mary University, Aix-Marseille University, and the Natural History Museum. And I study bacteria on glacier surfaces, and as well as the movement of bacteria and how they get to the polar regions, and how this bacteria might be adding to the biological and the different cycles that affect the atmosphere and different other cycles in the world. And I think one of the main things that we don't talk about really when we talk about the cryosphere is how these bacteria are also influencing the change of gases, are influencing the melt of the ice sheets of the glaciers on the surfaces, we have bacteria, algae that are also changing the albedo, which is something that we've talked about a lot. And we tend to forget to talk about the microbes. I think they're really, really important. They're affecting these biogeochemical cycles, not only on the cryosphere, everywhere in the world. And in the cryosphere, they have a very important role as well as to all the things that we've been talking about. So that would be my main thing. And obviously, I'm a microbiologist, so I have a bias, but I really do think that we need to think about them a bit more.
Thank you, Laura. And I'm quite sure most of the politicians underestimate the microbial activities on glaciers, so on ice. I'm very sure. The next speaker would be Josep. And would you like to introduce yourself briefly and share with us what do you think? What is the most maybe underestimated change in the cryosphere from your side?
Good morning, everyone. I'm Josep Bonsoms. I'm a researcher and teaching fellow at the University of Barcelona. Just completed the PhD about the impact of climate change in Greenland, focusing on the Greenland ice sheet and on peripheral glaciers of Greenland and in the snowpack. So I was analyzing how the snow will change in the future and which implications it has for the communities and for the ecosystem. And at the University of Barcelona, I also teach in physical geography, and I'm focused on the cryospheric elements such as glacial geomorphology, snow hydrology, or permafrost. So I think that one of the most, you say, underestimated effects is permafrost, because sometimes we don't include the greenhouse gases emissions of permafrost in the future simulations of the climate. So permafrost is one of these elements that we have in many land areas of the Northern Hemisphere. It covers around 20% of the territory. And it has many important implications for the local communities that are living in the Arctic. And sometimes we are losing the attention that permafrost requires.
Thank you so much, Josep. Yes, it's also called the carbon bomb. Huh? That is very true. Over to Ellie, please.
Hi, everyone. My name is Ellie Miller, and I'm a third-year PhD student at Colorado School of Mines. And I'm a paleoglaciologist and isotope geochemist. So I use isotopes to figure out what ice sheets were doing before the observational record. And specifically, my PhD focuses a lot about water, not only locked up in glaciers that translates to tangible sea level rise, but also the water systems within the ice and underneath. So what I've been thinking about is groundwater in Antarctica, and how oftentimes we don't think about this as a source or a contributor to sea level, but it seems as though we're underestimating the amount of water beneath the ice sheet by over 50%. So in not accounting for these systems in next generation ice sheet or sea level rise, we sort of miss the full picture of what is happening beneath the surface where we can't see, which has a lot of implications on how the glacier moves, what sorts of sedimentological features are formed, and where that water actually gets routed into our world's oceans. So I always like to draw attention to that. I think we always see pretty pictures of superglacial lakes and rivers, but there's a really complex hydrologic system beneath these ice sheets as well that are also big players in this story. Thank you.
Super. Thank you so much. Do you pass on the microphone to the other side? There was recently a Nature paper on continental drying and on the role of unsustainable groundwater use on the continents, and that how much that contributes to sea level rise. But groundwater under the cryosphere is certainly something that gets far too little attention. So we are reassured that you do your PhD on that. So that is helpful. And now it's a pleasure to invite Dr. James Kirkham to introduce himself and share with us, what do you think?
Thank you, Stefan. So my name is Dr. James Kirkham, and my title is the Chief Science Advisor to the Ambition on Melting Ice High-Level Group on Sea Level Rise and Mountain Water Resources. This was a group founded at COP27 in Egypt and now comprises 25 countries affected by the loss of cryosphere globally, trying to raise awareness and ambition on the need for emissions reductions here in the COP process. I also am a cryosphere scientist advisor to the JET Cryo group on cryosphere services at the WMO, looking at the services we need to maintain to monitor the cryosphere for a variety of reasons globally. In terms of the main messages. These have all been really fascinating scientific advancements and ideas about what's missing. From my perspective, I'm going to give a bit more about what we should be looking at here at COP30. And I think when it comes to the cryosphere, people don't often realize the irreversibility of the changes here, the sensitivity of the ice to near-term decisions, committing us to very long-term impacts, which we'll have to deal with for centuries, if not millennia to come.
Thank you. Clear statement. But if I may relate, was it Miriam or Florence? I think one of you made the point that are we keeping pace? You know, the changes in the cryosphere are so rapid, and they have long-term impacts. But sometimes we even while we study them, they're changing already so rapidly. So it's very difficult to say, well, this is the baseline, and of course this picture comparison we often have, and so but it's really a very rapidly changing environment. Do we keep pace, or where do you feel? What do we need to do differently? Reflect on that, please, because I think one of you made the statement. Florence, was it, or no? Miriam, doesn't matter. Laura, please.
From my experience, I think we are trying. We are trying as fast as we can to keep pace, but I don't think there's a way. It's really sneaking up on us. For example, I went to Svalbard. I mostly work in Svalbard, and we were trying to collect fresh snow samples to have some baseline data of what is going on in terms of the bacteria. And we were going to go for 2 weeks, and turns out that these 2 weeks we had a warming event that led to mostly rain. This was in February, where the temperature is meant to be around -15, and we planned everything around the fact that we were going to be able to collect all the snow. And most of the days, if not every day, it only rained. So we couldn't collect the data that we went to take. And we realized, oh, how do we have any baseline data? Is everything already been affected? So yeah, we're trying to get it, but it's happening faster than I think we expected, even as scientists.
Joseph, please, and colleagues from the audience, prepare your question. This is interactive. Feel free to ask the most difficult question to this highly competent audience panel here. Please, Joseph.
I think that sometimes in the climate community and in the snow hydrology community, we found that it's quite difficult to understand the processes that are happening. If we want to really know, for instance, why snowfall is happening and all the physical processes that is leading to precipitation, snowfall, and these hydrological changes. And this is difficult because sometimes we have the part of climate variability, the natural climate variability, but then we have the anthropogenic climate change that is affecting these natural processes. So sometimes it's quite difficult to separate what's natural climate variability from climate change. And even, for instance, in the World Meteorological Organization baseline climate period of 1960 until 1990, we have 20 years that were already affected by climate change since the 70s until the 90s. So it's difficult to make this differentiation and to better understand the processes of the hydrological cycle.
Yeah, thank you very much. It's a very important point. And what we take as the climate normal period to compare is already influenced. We understand that. But it's even worse in hydrology, I can tell you. We put the Global Water Resources Report together, and we take as the normal period 1990 to 2020, or 91 to 2020, actually. And in the 90s, particularly when the global warming really kicked in, it is very difficult to say this is the normal period and to compare with averages. So, but the point is very well taken, but we wish we would have much longer and more data, but it's, yeah. Ellie, please.
Yeah, I wanted to echo what Laura and Joseph said. I think it's absolutely true that we're losing a lot of these systems before we fully understand them. And especially from my perspective, coming from the US, a lot of this work is also being devalued. So we're losing out on precious money and resources to actually get this work done, which makes it really challenging to keep pace with the rate of change that this is all happening. So I just want to draw awareness to that we need more money. We always need more resources to answer a lot of these questions and understand these processes that are really hard to see logistically and access. So
Thank you. James would like to make a contribution.
Yeah, I think I can just add on to what Ellie and our other panelists have said there. Really, it's we're aware that the polar regions in the cryosphere are warming at about two to 4 times the rate of the global average. And yet, do we have 2 to 4 times as much money to monitor these incredibly rapidly changing systems? I see a few kind of wry smiles in the audience. Of course we don't. Our community is small. It's incredibly enthusiastic about this, a very dedicated community, but we're doing our best. But really, as we're saying, we are not getting chance to understand these systems before they go. And this is incredibly important to stress the importance of funding to actually secure this for a better understanding for the whole world.
I fully agree. At WMO, last year we finished a report for Central Asia and looked at the monitoring network and places like Tajikistan, which are highly dominated by high mountain region. And we called a high mountain weather station above 3,000 meters. What do you think? How many stations in Tajikistan above 3,000 meters elevation altitude? Give me a percentage, maybe each of you. How many stations do we have at the high mountain region to observe one of the most important water resources and glacier systems of the world?
That is a very hard question. I mean,
it's not an exam. I was just
no. I mean, so I was lucky to, after the conference this year in Dushanbe, to go out to the mountains for about 5 days and walk around there. And there's no infrastructure at all, even in the west, which is even more accessible than the east. So I would say maybe less than 5%.
Okay, he's an expert. You can see. So he passed the test. It's actually, according to our statistics, it's 3% of the stations that are above 3,000 meters. So we often use stations in the valleys or outside the main mountain regions to interfere of what's happening at an altitude at an area which is very difficult to access. So that is one of the challenges. Other questions? I'm looking to the audience. Colleagues, please. We have one here. Rita, if you could help with the microphone, thank you.
Hi, I'm Caroline. I work for a nonprofit here in Brazil called Comunitas that works with public administration. Well, I've been keeping up with the theme of climate refugees later during this week. And my question is, well, I believe that for us to prevent the amount of climate refugees in the future, we have to work with scientists like you all to preserve what we still have in our Earth. And then my question is regarding what James and Ellie said. It's a small community and financing is still a challenge. I believe mobilization is a way for us to get more financing and also bring awareness of the community. How can we do that, and how can we mobilize the civil society for them to understand the needs for us to finance and invest in research and more programs that can preserve our land and also prevent climate refugees in the future?
Thank you. That's a complex question. Who dares to answer this one?
I can give it a stab, perhaps while our other colleagues have a think about it. In terms of what the sort of grassroots community can do, I think a genuine problem we face is that what is happening in these faraway regions often feels so disconnected to the impacts we're feeling on the ground here. So I believe in that regard, we need to be telling more stories about how impacts on, say, small island developing states are being affected by loss of cryosphere and accelerating losses, for example, and to really mobilize and make awareness raising of the importance of actually funding these systems so we can monitor what's happening there. We can provide early warning systems to work out when these events begin to happen, when things start to tip. Anil earlier pointed out there's a huge variety of a lot of focus on these issues in the coming decade. This International Year of Glacier Preservation kicked that off, but I really hope that over the decade of action for cryosphere sciences, this can continue to be really at the forefront of issues here. And of course, as Stefan said earlier, we can't afford duplication. Like, the money is pretty scarce here, so we have to make sure we're working together, we're coordinating with each other, and we're not reinventing the wheel. So if we do that combined, I really hope we've got a really positive outlook for the next decade.
Very good question, but difficult to answer. I think that one example that we are now following in the scientific community is to translate this lack of snow into economic losses and into the impact that it has for the population. So we were talking about, for instance, Tajikistan that has a very important resource of glaciers and snow, but there are other countries next to Tajikistan that depend on the water of the mountains of Tajikistan. It happens, for instance, the same in Southern California, that there are large cities next to the mountain area that depend on the snow cover. So I think if we can translate these physical changes that we are observing into social aspects, and we quantify these losses into economic losses, it's a big change and a big improvement of the climate change studies that we are reporting.
Yeah, I would also echo that as well. I think we have to get a little bit more creative in how we're telling this story. I think often as scientists, we write papers and we put them out into the world, and oftentimes they don't always have the impact we want them to. So diversifying our means of communication and really understanding what stakeholders and community members value in terms of communication, and also letting them drive those efforts. I think that is the most impactful way forward, and sort of this like co-creation process that can actually really tie people to these issues and create a lot of investment at a local and regional scale as well.
Thank you. We have a question from the audience.
It's not really a question. I just wanted to add a final comment to that. I mean, we are in a decade of conflicts, a lot of wars around the world. I think we talk about scientific collaboration, but cooperation is the key to share the research infrastructures and strengthen the observational networks and raise awareness among populations. So cooperation is really important, more than ever, I would say.
Thank you. We have another question. Maybe we can get this in the back. Two questions, please.
Hello, thank you. I'm a scientist, so I'm also very familiar with the lack of funding to measure everything that you want to measure. There's never enough. But I wonder if you could comment on new technologies. So if you compare from 20 years ago, you could probably do a lot more measurement with the same amount of money that would buy one station. And I wonder what kind of new technologies you're using for the cryosphere. Thank you.
Good. There's the next question there. Who wants to respond to the new technology? We have isotope tracers here. Thank you.
I don't know if this is not a new technology by any means, but I think there's so much evidence and information that's been left behind by previous glaciations that we still have only barely scratched the surface on. So I think there's still a lot to explore in terms of how these processes and systems have evolved in the past, and that doesn't require any sort of new machine or new measurement tactic, but again, more resources for accessing these specific records and archives, both in terrestrial sediment cores, ocean sediment cores. So I think there's still a lot of unknowns in the paleo record that can sort of fill in these gaps in the questions we're trying to answer today.
I think in snow hydrology, for instance, one of the newest technologies available is data simulation. So we are correcting the models with observations, and each time we're improving the predictability of runoff, for instance. Another improvement that was developed in the last years was machine learning, and there are many machine learning algorithms that are being used for glacier and for snow models. So in the end, each year the technology that we have is improving, and I think that we are getting closer to have a very reliable prediction of the future evolution of snow or glaciers.
Thank you. I want to give a perspective from the Pacific Islands. My honorable minister is here. We've come here to probably to listen to this. It's very, very important for Fiji. Fiji continues to be the mouthpiece for Pacific small island development states. We don't have any glaciers. We have ocean acidification. I want to reiterate the call by Madam here on the great need for us in the Pacific, climate science, data, evidence-based information, this is so critical for policy decision making. And I'm so thankful that I see some young researchers. Great. I am a growing old man. That is a big champion. I always champion young. All our 14 member countries, we have a youthful population. This is something. My question is, what's the possibility for greater collaboration and maybe a North-South sister partnership in our academies? We have in Fiji, we have 3 universities, a regional university and 2 national universities. 2 months ago, we had another 4th university, we call it Pacific Community University. Now, I want to bring this, the whole idea of climate science needs to go down to the grassroots people. And this is where I ask for the panel, what is the vision or what is the aspiration towards this so that we don't leave any stone unturned, meaning for us in the Pacific, our Honorable Minister says, we are not only small island development states, we are big ocean states. And we are treating this ocean as the ocean of peace. How can science come for us to help us so that we can justify climate financing, which is the main issue for us in the Pacific? Thank you, sir.
Thank you, sir. The changes in the cryosphere don't remain in the cryosphere areas, but are certainly felt in coastal regions and in the small islands and the Pacific in particular. Who wants to speak on the role of science? Please, Laura.
I completely 100%
to-
agree with you. I think it's so important to consider science from all spaces, from all views. I'm from Colombia and I study the polar regions. Colombia is in the equator, we have glaciers, but we don't talk about them. I think it's so important to not just have young voices, but to have young voices coming from different places of the world, understanding the world in different ways, because that also informs the way that we do science. Our backgrounds influence the way that we ask questions. What questions are we asking? And yeah, 100% I agree that we need, and this is a problem in science in general, we need to have more diverse voices, collaborating, working together, not only in the cryospheric space. And in fact, you know, our pavilion is an Iceland-Chile pavilion. We're working Global South with Global North together in working towards something that we all care about, which is climate change. It's the polar regions in the top, in the bottom, all around. So yes, it is so, so important. And I think we see that here at COP more than ever.
That's an excellent answer, Laura, so thank you for that. I would just like to really draw and thank you for, so Your Excellency, thank you very much for being here and attending this side event. Thank you to Fiji and also the wider AOSIS coalition for not just being the mouthpiece for science here, but being the shield for science and against misinformation, disinformation that we have been experiencing here at this COP. I was in the research track of negotiations here last night until nearly midnight. And AOSIS has been continuously defending the role of science, the importance of IPCC for not just your nations and the coalition, but for the entire world here. Now, this is entirely the point of our coalition of countries who are trying to fight this. The idea is that this is not just about places that have ice, it's countries who are affected by it. And we've seen increasing uptake by AOSIS states. We had the president of Palau last year sign onto our declaration and become the latest member of our group. I would formally invite you to join the group or consider joining the group at this COP and to lend your really important voice to this process. We really value you being here. We really value your efforts and your appreciation. So thank you very much.
Thank you, James. Your Excellency, Honorable Minister, would you like to respond to that? But certainly you don't have to. I don't want to put you too much on the spot, but there's a microphone coming, by the way.
Thank you. You know, sometimes we always think that there's a big injustice happening when you talk about climate change. We are from the region where we contribute almost zero, or least, of all that is happening to the world now in terms of this emission. But we are the one that is getting the, was punished for this. Yeah. So as mentioned by my colleague, the justification here and how can we be assisted by those that are really contributing a lot to this problem to help us, because our islands are underwater now. We have to relocate villages. We have to reconstruct all our roads because of this rising sea, breaching of the corals, driving away the food and all these things that we depend on of the sea. Small rains are causing floods now.
Yeah.
These are the problems that we are facing, and we are coming and listening to those that can say something that will assist, that will make meaningful to us. Probably science can contribute on this, on how we can also educate our people to understand the changes. When we touch our sea and when our islands started to go under the water, it's like our generations are gone. Our identities washed under the ocean, so forth. I'm thankful that I'm here listening to all of these. It's really encouraging, especially when I see the young generation talking this, something that we really want to go back and tell our people back home, especially our generation, things that they need to understand. But what's really happening, it's not a joke, it's nothing, this is real. Thank you.
Thank you, Your Excellency. Very, very important, and we really appreciate making the time to join us today. Is there one final question? If not, I will ask the four panelists. You have 1 minute each for a key message to our policy and decision makers. Do we have one more question from the audience? And also would like to invite the two keynote speakers who are still there to share with us. You have a question, please. A short question, please.
Hi, my name is Francine. I'm from Brazil, and I'm a president of an institute, an NGO, about the outreach and education about Antarctica. Gelo na bagagem is like ice in the luggage. And I want to know about your ideas or outreach and education in the internet. How can we get the politicians or decision makers under the internet? How do you, what do you think about that?
So on the importance of outreach and communication, anybody would like as a solution? Usually, they are all super active, in social media. So I know this from my kids. So this is amazing. And if there's not a direct response, Florence, please.
Well, I mean, so there are several programs for education through universities and also through high schools. And I think there is an association called Polar Educators. You can reach out to them because we as scientists are part of it, and Polar Educators are also reaching out to us, and they try to raise their own teachers, their own outreach communicators all around polar science, and you can find them. You can reach out to them because they have several resources and programs that works very good in your case, for your case.
Thank you so much. We have to draw this session to a close, and I would like to invite all the panelists, and if the keynote speakers who are still here also would like to share one message. I think Miriam showed us super interesting trends of the changing cryosphere, but also very frustrating trends of the changing cryosphere. What would be your message to the political leaders? Fortunately, we have one Excellency, Honorable Minister from Fiji here in the audience, and it's the end of the first week, and there's some conference fatigue coming in, I think, for us. But for the next week, so what would be your main message for the changing cryosphere you would like to share with the policies and decision makers? Who would like to start?
Okay. I guess my message is very simple. I think I would encourage them to listen to the young voices in the room, listen to the activists, listen to the indigenous perspectives, the people that are directly impacted by these changes. I think oftentimes those folks don't get a seat at the table, but those are the folks we need to be listening to most importantly now.
I think the best message that we can give is that the race to preserve the cryosphere is not lost. And if we look at climate projections of glaciers, for instance, we know that each degree of temperature matters. So if we can stabilize the increase of temperature, by the end of the century, we can have a huge difference of the glacier preservation. And it's the same for snow. In the next decades, if we can follow a mid or a low emission scenario, the difference of following business as usual or a high emission scenario is very high. So I will want to highlight this important implication for especially here in COP30, because the negotiations that are happening here are very important for the future of the cryosphere.
Thank you. And I would just like to reiterate again that we need to continue funding the science. We need to continue doing the science to understand what is going on so that we can understand what is going to happen. We need to listen to the scientists. We live in a time when scientists are being maybe not trusted in the public, and it is important to give space for the scientists to have these spaces in the decision making. So I think, yeah, that would be my message.
That is brilliant. I sit here with two hats on, really, so I'm going to be a bit cheeky with Stefan and a sleight of hand. From the jet cryo perspective, we need to continue to fund and maintain and monitor these systems so we know what's coming, we can deal with it. But from the perspective of someone, a scientist sitting in these negotiations and following it, science is not up for negotiation here at COP30. What we've seen so far is unacceptable in terms of how difficult it has been to reflect basic scientific messages in these negotiations, and we have to take a stand. So I invite you, those of you in the audience, to follow this as we go into week 2.
So we've been discussing different regions of the world, the high mountain areas. We've been discussing the Arctic and the Antarctic, but cryosphere is not a regional problem. This is a global problem because of sea level rise. So any island states, any countries with a coastline, or any countries involved in global trade could be affected by migration. So basically everybody, they're all affected. Sea ice is in the Arctic and the Antarctic. It affects the albedo of the Earth, so it affects everybody. So when we're talking about the cryosphere, we're not talking about a few island states, a few mountain countries. We're talking about all the countries of the world. We should be concerned about the changes in the cryosphere that aren't just happening rapidly, but the changes are getting faster and faster. Thank you.
So on the very practical way, as we said, I mean, the cryosphere is going away. So we need to adapt, and adapt means two things. We have to translate our science into actionable science, and that's a very important aspect for new generation. Not only stay on the science, but also try to translate what numbers mean in terms of hazards for populations, and also for the authorities, local authorities, to adapt, because we cannot avoid it. So start now. Do not wait, because science will still monitor, but sea level will rise and climate will change. It's already occurring. So adapt. That's now. I mean, don't wait for a better report. Don't wait for better numbers. It's a waste of time.
Thank you so much. I definitely enjoyed this session. I think we should give a big hand to this excellent panel and the speakers. Ladies and gentlemen, Your Excellency, thank you so much. I wish you a good COP. May I invite the speakers just to come to the front for a family picture. Thank you. Have a good COP.